Recall from the other video that we talked about independence and dependence of functions. So if we have a list of functions, f1 of x, f2 of x, and let's end that at fn of x, then these functions are linearly dependent if there exists some constants, c1, c2, up to cn, and one condition is that they're not all zero, such that the linear combination c1 f1 of x plus c2 f2 of x up to cn fn of x is equal to 0. So if there exists non-zero constants, or at least, well, some of these could be 0, but not all of them are 0, that make a linear combination that's equal to 0, then the original list of functions is said to be dependent. If it's not possible to find non-zero constants that give us a 0 linear combination, then the original list of functions would be said to be independent. What we need to do now is to look at a better way of determining independence or dependence for functions. And so that's where we get to a topic called the Wronskian determinant. So the Wronskian determinant is just defined as follows. And to keep this a little bit simpler, I'm going to assume that we only have 3 functions. So let's say we just have an f1 of x, f2 of x and an f3 of x. Then the Wronskian determinant for these 3 functions is defined as follows. We'll call that W for the Wronskian. Its determinant with the 3 functions occupying the first row of the determinant, and their derivatives in the second row, and their second derivatives in the third row. So that's all there is to the Wronskian determinant. So you can take, of course, more than 3 functions, but then you'd have a larger Wronskian determinant. Remember, all determinants need to be exactly as wide as they're as tall. So if I put in an f1, an f2, an f3, and then extend that maybe to an f4, well, then I'd have to put more derivatives down here. I'd have to have the first derivative, the second derivative, and the third derivative to keep that being a 4x4 determinant. But in this class, we'll just have to go up to the 3x3 case. So this is really the maximum size we'll be looking at. Well, let's look at an example of 3 different functions. And f1 of x equals x squared plus 1. f2 of x equals just 1. And f3 of x equals x minus 1. So there's our list of functions. Now we might be wondering, is that list an independent list? And the Wronskian will help us answer that question. It turns out that if the Wronskian is not equal to 0, then we have independence. So in some cases that just gives a convenient test to test a list of functions for independence. Let's go ahead and compute the Wronskian on this example. So we have the determinant, and in the first row we just list the three functions. Then we take the derivative of each function, and then the second derivatives, and that's our Wronskian determinant. Next thing we need to do is to evaluate this determinant. And recall that when you evaluate a determinant, you can expand across any row or any column. And if we look at the third row, we have 2 zeros in there, and that makes it a very convenient row to expand around. So I'll choose that row. So I'll begin here with the 2. And then what we do with determinants is to pretend we're crossing out the first, or the row that contains, crossing out the column that contains the 2, and crossing out the row that contains the 2, and just looking at the 4 entries that are left over. So we have a 1, a 0, an x minus 1, and a 1. Then we would move on to the next entry in our third row. And since that's a 0, it's going to have 0 contributions, so we don't really have to really do anything there. It's just automatically a 0 there. And then move on to the third position, and that's also a 0, so that it has 0 contribution. And then we need to do this 2 by 2 determinant, and we can do that by cross multiplication. So we have 1 times 1 is 1, and x minus 1 times 0 is 0. So we just end up with a 1 here. So we have this 2 that we had before, and then cross multiply, we get a 1, and 2 times 1 is equal to 2. So what we learn from this is that the Wronskian is not equal to 0 for these three functions, and therefore the three functions are independent. So therefore f1, f2, and f3 are independent functions. And that's just a simple example of how we can use the Wronskian to decide on independence.